Hello students and welcome to part 2 of Unit 6 Part 2 Lesson 2. In this lesson we are going to continue to discuss scatter plots and lines of regression. Let's begin by looking at this sample multiple choice question. It reads, based on the line of best fit, what is the expected distance Bobby has traveled after 8 hours? So in other words, we're looking for the number of miles that he traveled after 8 hours. If we look on the x-axis, this is the value, 8 hours. If we go up on our line of regression, we can see that on the line of regression, at 8 hours, the distance traveled would be 400 miles. In other words, this ordered pair is 8 hours, 400 miles have been traveled. Now let's move forward with how we can write an equation for a line of regression. There are two ways to write an equation for a line of regression. Our first option is the first way that we've ever learned to write an equation, and that is using slope-intercept form. This is useful if you can accurately identify the y-intercept and the slope using rise over run. If you cannot, you will need to use point-slope form if you can identify two perfect points on the line of regression. We're now going to look at an example of each. This graph is a graph that represents the relationship between the number of times that you attempt a free throw in basketball and the number of points scored in a basketball game. If we want to write an equation, we have those two options that we talked about. The first option is slope-intercept form. This form, which if you remember is y equals mx plus b, where m is the slope and b is the y-intercept, is useful if we can identify the slope and the y-intercept on this graph. Well, we can find the y-intercept on this graph by looking up and down the y-axis, and we see that it intersects here at 0. It is a very clear point as to where it crosses. Had the point been in between two of the lines, it would be more difficult to accurately say what that y-intercept is. Now, to calculate the slope, we need to find another perfect point so that we can do rise over run. So I'm just going up the graph until I see where it intersects at a perfect point, and I find one right here at 8, 3. Now, I'm going to use rise over run to calculate the slope between these 2 points. Well, if I wanted to go between these 2 points, I'd have to rise 3 and run 8, so my slope is 3 over 8. So I'm going to put that where the x is, m is. So our equation is y equals 3/8 x plus 0, or y equals 3/8 x. We can now use this equation that we just generated to make a prediction about a certain situation. Here's our situation. If this player were to attempt 150 free throws during the season, how many would you expect him or her to score? Now, obviously, we cannot use our previous strategy of extending the line because we're only at 16 and we're talking 150. That would be quite a task to extend it that far. But we do know that 150 is the number of attempts, or the x value. So we know that x is 150. We just have to figure out what y would be. So we can substitute 150 in for x to figure out what y is. So y would be equal to 3/8 times 150. Now remember, 150 is 150 over 1. Now we'll multiply straight across. 3 times 150 is 450. 8 times 1 is 8. So we need to divide 450 by 8. So if we use our calculator, we can do 450 divided by 8, which is 56.25. So y is equal to 56.25. Now, free throws need to be whole number free throws. You can't make a quarter of a free throw, so we would have to round this down to 56. So we can expect this player to make 56 out of 150 free throws. And we would write that in a sentence if we had a little bit more room. Okay, now we're going to look at another example, but this one we're going to have to use point slope form. This graph is a scatter plot that shows the relationship between the number of workers available and the number of days it takes until the job is complete. Now, for this one, we're going to use option number 2. We're going to use point slope form. The reason we're going to use point slope form is because if you look up and down our axis, our given graph does not intersect anywhere on the y-axis. It would, if we extended it, we would see it would probably intersect up here, but we cannot get an accurate measure of what that is. So instead, we're going to use point slope form. To use point slope form, identify 2 perfect points on the graph. So for example, right here, I see a perfect point. This is the point 2, 25. So one point that I can use is 2, 25. Another point that I could use, and I can pick any one, I'm just going to pick this one right here. This is the point 10, 15. Now, just like you did in Unit 6, Part 1, we're going to use these 2 points to calculate the slope using the slope formula. Remember, slope is equal to y1 minus y2 over x1 minus x2. So we have 25, which is y1, minus 15, which is y2, over 2, which is x1, minus 10, which is x2. 25 minus 15 is 10, and 2 minus 10 is negative 8. So our slope is negative 10 over 8, which reduces by 2 to give us negative 5 over 4. Now we can start to write our equation because we know that the slope is negative 5 over 4, and we know a point. It doesn't matter which one we use. I'm going to use 10 over 15, 10, 15. Now, we know a point, we know a slope, we'll use point slope form. So we use y minus y1 equals m times x minus x1. Substitute our values, so we have y minus y1, which is 15, equals m, which is negative 5 over 4, times x minus x1, which is 10. So we have y minus 15 equals negative 5 fourths x. Now we take negative 5 over 4 times negative 10. A negative times a negative is a positive. 5 over 4 times 10 over 1 is 50 over 4, which can reduce by 2 to give us 25 over 2, which we know is 12.5. So we have negative 5 over 4x plus 12.5. Now we add 15 to each side. Okay, I'm running out of room, so I'm going to move our equation up here to the top. Okay, I'm going to put it right here. So if we add 15 to each side, these cross out, and we get y equals negative 5 over 4x plus 27.5. So this is our equation that represents this situation. We can now use that to make a prediction. Okay, here's our prediction question. Approximately how many workers would be needed to finish the job in only one day? Now, remember, days is the y value, so we need to substitute 1 for y. So we're going to say 1 is equal to negative 5 over 4x plus 27.5. So to solve this, look on the algebraic side, we need to get rid of our constant, so subtract negative 27.5. So we have negative 26.5 equals negative 5 over 4x. Multiply by the reciprocal, multiply by negative 4 over 5, because those will equal 1. Multiply by negative 4 over 5. We're left with x equals, now remember this is over 1, so we need to take negative times a negative, which is a positive, which makes sense because it's going to take a positive amount of workers. Multiply straight across, so we'll do 4 times 26.5, and that's 106 divided by 5, because 5 times 1 is 5. Divide that by 5, and we get 21.5. So x is equal to 21.5. So that means we would need about 21 and a half workers. But since we cannot hire half of a worker, we'll have to round that. If we want it to be accomplished in one day, we're going to have to round that up to 22 workers. Equations can be used to make predictions. Here's a sample multiple choice question. It says, the graph below shows a line of best fit for data collected on the amount of liquids consumed by a runner in relation to the distance he ran. The equation for the line of best fit is y equals 3 halves x. Based on the line of best fit, what volume of liquids will the runner consume when he runs 7 miles? Now, you could go up 7 and over, but because it's between, we don't know if it would be 10 or 10.5, but we know it's going to be somewhere in there. To be more specific, we can substitute 7 in for x. So we know that y, which is the volume of liquids, is equal to 3 halves times 7. Well, 7 over 1 is the same as 7, so we'll multiply across. So y equals 21 divided by 2, or y equals 10.5. So 10.5 fluid ounces would probably be consumed by this runner if he or she ran 7 miles. So let's summarize what we've learned. A scatter plot is a graph used to show the relationship between bivariate data. The correlation describes the relationship in general, but a line of regression and its equation can describe the general relationship more specifically and allow predictions to be made based on data. The line of regression can be used 2 ways to make predictions. It can be used as it is or extended upon to look for ordered pairs already on the line of regression. Or 2, an equation can be written and used to calculate any prediction. When writing an equation, slope-intercept form and point-slope form can both be used.